So welcome back. We are going to solve another type of problem now. Till now we were maintaining the count or sets in the sliding window, right? Now the problem is different. What we are going to do, we are going to find out the max element in each window. Okay, what does it mean? Means suppose one number array is there given. Suppose a random number I have taken. You can take negative, positive, everything. Okay, some number randomly I have written, and let's say k equal to 3. So this is the window size. So what I am saying, for each window you have to find out the maximum number. So like in this, what is the maximum number? 3. So to create one array, so in first window this is 3. Second window, what is the maximum number? That is also 3. In the same way, third window, what is the maximum? That is 5, right? Then again the sixth window, this one, again 5. Then again this one, 6. Then again this number, 7. And now window is over. That's okay. So this should be the output. So hope the problem is clear now. So for every window of size 3 or size k, we have to find the maximum. Okay. So if I want to do without sliding windows, so what should be the approach? Just think. Pause the video. Think. So the naive approach would be like, I am going to take each window and scan it. Okay. So like this is one window, 1 3 comma minus 1, so max element. Then again second window, 3 comma minus 1 minus 3, this is 3. In this way I am going to find out all the maximum numbers, correct? And I'm going to put that in a one array. So the complexity I'm talking about, so complexity will be, for the larger input this is going to be very slow. So the time complexity will be like n, I have to scan each and every, plus k size, this is a repeating word. So every k size I'm going to do this same operation, finding the maximum, and this is for the scanning the whole array. Okay, so what is the key challenge over here? So when window moves, one element goes out and one element comes in. This is a part of when we are going to do sliding window, right? Okay, so in the same flow, when one window is getting moved by one place, so one is getting out and one is coming in, at the same moment I have to store the max element efficiently. Okay, so how to solve this? So in sliding window, what is happening? This is one window, 1 comma 3 comma minus 1. What is happening here? In this window, one element is entering and one element is leaving, right? So I know that if I found out some data structure where when I enter any element and remove the unnecessary element, what does it mean? It means that suppose there is 1 comma 3 comma 5, this number is there, and if 6 is coming, for me this number are useless in this case, because 6 is greater than the 5, right? So if the current element is greater than the previous max, then rest element, I mean the other elements lower than that, is useless for me. Okay, so why I want to remove the smaller, I mean what does it mean? So if a bigger element comes later, then a smaller will never be max again, that is for sure. If 5 is coming here, then all the smaller will never be max again, because already max to them is already here. So whenever you're going to choose max, you are going to choose this, not the max on this. And to store this in a decreasing order so that front is always maximum, I want to keep the front element always maximum. So one data structure, if you remember Deque, this data structure is store only each would element in a decreasing order so that front is always the maximum. Okay, so you can imagine one analogy, like suppose you want to track the tallest people in a movie crowd. Okay, some crowds are there, they are going somewhere, and you have to find out the tallest person in that group. So if a taller person comes, shorter ones behind that doesn't matter to anymore, because you want to find out the tallest. You got the tallest, the rest is, there is no use of it. So this is a concept that we are going to use. So we are going to use Deque here because finding out the max element is a very faster one, is I think order of 1. Okay, and I want to remove the useless element, so I have one condition like, okay, except the front element, rest is useless for me, so remove that, and also maintain the order. So that's why I am going to use Deque data structure for the removing the element, right? So to understand the Deque, let me take one example. I'm not going to the main problem right now. I just want to explain like why we are going to use the Deque. Okay, so let me take one example. Suppose I'm having some number 1, 3, -1 simply. So I'm going to Deque the first number. It comes like that, right? In step 2, suppose this is step 1. In step 2, when 3 will come, then what will happen? 3 comes, then I'm going to remove 1. So Deque will be having now 3, because 3 is the bigger element. So if bigger element is coming, it's already where 3 is greater than 1. In that case, 1 is of no use for me, so I can going to remove that. Okay, and Deque give this method like Deque dot peak first, right? Okay, so this is done by in this way. Now step 3, when -1 is coming, then what? So -1 is coming, then I'm going to add, because it's not bigger than 1, is not bigger than -1, not bigger than 3, so I'm going to Deque that also, 3, -1. So always the front element is always the biggest element, right? So when I do this method, I'm going to get the biggest element or largest element. So this is the concept that I'm going to use in the solution. Okay, so now let's come to the solution now. So the concept is, whenever window moves, okay, whenever window moves, one element comes in and one element goes out. That is for sure. In the same process, we have to update the max efficiency I told you. So for this, I'm going to use Deque, because I know that in any point of time, the front element is the highest element. Okay, so we are going to use Deque to store the indices of element in decreasing order. Okay, so whenever any current element is coming, I'm going to compare. If it is greater than the last one, then remove the last one first thing. Okay, this is a rule 1. So let me write the point that I want to say, because at every move I have to find out this max. I have to store this max element, right? So what could be the one condition? If the current element that is coming, if, let me write this, current is suppose greater than last current, last element in the Deque, then remove last, because I already got the bigger element than that. So now not any previous element is going to be max now. Rule 2, it says once you've done this, then add the current index in the Deque. So in other case, I'm going to add the current index. If it is not less than that, add current index, right? Then what could be other possibilities? Tell me. So when the window is moving, so suppose size is 3. So when this portion, after 2 movements, it will come here, and after that it will be completely gone. So we have to remove the out of window index from the front. Window index from front, correct? Because there is no issue, because my window is now here, so whatever the max was there, that is okay, that is done now. And rule 4, the front element always a max element, that you have seen in the Deque property, right? Okay, so let's take one example and do the dry run so that you can understand the pattern. So I'm doing the dry run. Suppose you are having the number 1, same number I'm taking. Okay, and K I have taken 3, that is window size. So we know that Deque is going to store the indices. So let for I equal to 0, what will happen? This is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so for I equal to 0, num 0, what is the element? That is 1. So in the first elements I'm going to add in the Deque. Deque is going to have 0 for now. Remember this is the indices, not the value. Index I am saving, right? Now I equal to 1. What number is coming? For I 1 equal to, that is 3. Now 1. Okay, so I mean for the Deque index, whatever the index is here, that is 1. So 1 is less than 3. We got the bigger element, the remove 0. Okay, so Deque I remove 0 now. So now Deque I am going to add 1. So Deque is having now 1 index, but this is the biggest element now, till now in this window. Now coming to step 3. nums 2 equal to which number? -1. Okay, so what are the last index? 1. So what I'm going to do, since it's not a bigger element than the previous elements, I'm simply going to Deque that. So Deque 1 comma this index 2. So 2 elements, 2 indexes are inside this window. So now window already framed because it is a third index. So window is formed now. So what is the max in this window? Always the first element is the biggest element. So Deque 1, what is that? 0, 1, 3. So this will be giving you 3. So we have got the max element in the first window. Okay, now let's do for I equal to, we already done for 2 now. Now let I equal to 3. So for I equal to 3 now, see what num dot 3. So 3 is nothing but 3 is -3, right? 3 is -3. Of course it's not, it's not bigger than the last element. So what I'm going to do, I'm simply going to add in the Deque 1 comma 2 comma third index. Now here we have to remove the out of index window also because we have got the 3 element, right? We have cross the one window. Okay, so we have to remove the out of window element. Okay, so how to calculate the window element? Total 3 size. If I equal to going to cross 3, it means I have to do I minus k equal to 0. If this is happening, means window is complete. So in this case, I equal to 3, k equal to 3, this is giving 0. So means window is complete. Then index 1 is still valid, right? So 0. So do we have the current element, that is minus 3? Is there any Deque at the first position, whatever the number is there? This is the index actually. So at 0th, what is there? 1. Is there any number which is greater than 3? Minus 3 is less than minus 1. Then we are not going to change anything, right? Because it's a lesser number. So I will keep this. That's why I have added the index in here. Okay. Now, since this window is complete, now you have to find out the max one in this. So which one is the max one? The first element, right? So nums 1 is the max element, and that is I think 3, right? So again, the second window also we have got the 3 element as a highest. Now coming to I equal to 4. So in I equal to 4, what is the number? That is equal to 5, right? Yes, 5. 5, 3, 6, 7, 5. Okay, remember that. 5. So we first have to remove the out of window index. So I minus k, what is that? 4 minus 3. Okay, I minus k, 4 minus 3, that is equal to 1. So now I'm going to check Deque is having 1, 2, 3 already. So front is 1. Yes, front index is 1, right? So I'm going to remove the index now. So what will be now? Deque will become 2, 3. 1 is removed. So index 1 is outside window of 2, 3, 4. So we can remove this. Now removing the smaller element. So which element is coming? In nums 2, what is the number? Minus 3. It is less than 5, current element. Yes, then remove it. Because if bigger number is coming, then remove all the unnecessary smaller number. Then num 3, this one. What is this number? Minus 1. 5 is greater than minus 1. So you remove this also. So Deque again become empty now. I have removed each and every element now. Right? And simply I'm going to add the current element. So Deque will become now only 4th index. Correct? So what will the max between, in current window? So of course nums 4, because there is only one element. So nums 4 equal to 5, that is the max in this window. Correct? Now let's take I equal to 5. So what is the number? This nums I equal to 3. So first I'm going to remove the out of windows element. So I minus k, that is nothing but 5 minus 3, that is 2. Second index, right? So Deque 4 is there, right? That's okay, because 2 is not present. So this will be still inside. Now coming to the current element. So 3 is less than 5, Deque 4, and 4th position, whatever number we are going to compare with the 3. So yeah, it's true. Okay, so let's keep it. Smaller we have to remove, remember that. Okay. So now Deque will have 4, 5. right? And in this, the first element is the max element. So in this window, the max will be 4, that is nothing but 5. Okay, now coming for I equal to 6. So what is the sixth element? Sixth element is the 6 itself. So I'm going to remove out of window index, so I minus k, that is 6 minus 3, that is third element. So does your DQ is having this element? No. Okay, then okay, we are simply going to check, like, is there any number which is smaller than the current element, then remove it. So DQ fourth index is number 3, so 3 less than 6, current element, yes, so remove this. Second element is 5, so num 5 equal to 5 is less than 6, yes, remove it. So these are all indexes, remember, since I have memorized the number, so I can easily find it out. I have okay, so remember this index coming from here. Okay, so again DQ will become empty, and I'm going to add simply the current element, right? So DQ will become the index 6. I have added that now. So what is the max now? There is only one element, so max will be num 6, that is nothing but 6. Now coming to step 7, so that is I equal to 7. So in I equal to 7, num 7, let me find out. So num 7, that is equal to 7. So I'm going to remove out of Windows element, so I minus k, so 7 minus 3, that is 4. So does your DQ have this index? No. So let's keep it. Now I'm going to check whether the element whatever present in the DQ is less than the current element or not. Okay, so 6 is there, 6 is less than 7, yes, then remove it because you got the bigger element. There is one element, so DQ again become empty, and after that I'm going to add this element in this. So current element I have added. So now I have to find out the max. So there is only one element, the first element will always be the max one. So num 7 is the max element. So what is the final result? If you combine all the max that you have calculated, like 3, 3, 5, 5, 6, 7, correct? So this is the final result. Okay, so first thing, like, why we are removing the out of window element? So why are removing out of window? Because that element is no longer a part of current window and it cannot contribute to the max simply. Okay, so that element is no longer part of the current window, so it cannot contribute to the max. That's why we are keeping it out. And also we are removing the smaller element because they can never become maximum again, because one number is already coming in that window which is already maximum. So others, if less than that numbers, there is no need to keep that. So 2 points you have to go again when you go through this video, just go through 2 or 3 times so that you can understand 2 points here. Why remove out of window element? Okay, second, why remove a smaller? So these 2 questions are there. Okay, so front removes the expired element and back removes the useless element simply. Okay, so hope things are clear to now and you were able to understand this workflow, like how we have done this and what was the new approach, what are the problem in that. So okay, so let's see the code for this in the next video. Okay, until then, bye.